to watch the video that I'd posted. Also, has everyone gotten their web work notification? Okay, and the notification was sent out, and there was a little bit of a delay in getting the assignments posted, but there should be 3 assignments on there for you to try. One's an orientation one, and so if suppose you had that for an answer that you had given to a particular problem. So not all of the questions are multiple choice. And so if you wanted to know how to enter that orientation homework assignment says this is what you would do. So that's what you would type in on your computer. So it's a really good way to introduce you on how to put in answers. If you had say an interval and you wanted to put that in, then I think, now I can't remember if you just do inf or if it's actually the word infinity, but you do negative infinity, comma, positive infinity. It might just be inf. I can't remember off the top of my head, but there's, if you had something, if you wanted to enter that in, then you would type that using the shift key and the 6 on your computer. So any kind of mathematical expression, that orientation exercise just takes you through how to enter stuff like this in for answers, because it's not all multiple choice. There are some multiple choice questions on there. So there should be an assignment called Functions 1 or Function 1, and that's going to do with evaluating functions. So that was part of that video that I posted. And there's also one called Domain and Range. So we have very limited, at this point, lessons on how to get domain and range. So for example, if, let me just mess with the lights for a little bit here. Okay, if you were to see something like this, that's a function, and we can see that the domain would be the set containing Elvis, Colleen, Kaylee, and Marissa. So I've got the 7th edition of this book, the latest edition. So the pages and the problems won't match exactly. So if it's not matching yours, don't worry about it. The range would be the set of birthdays. And then we also looked at functions given and relations given in this form, and the domain is going to be the set of all the first entries, and the range will be the set of all the second entries. So then we had a video from what we missed on Wednesday, determining whether an equation defines y as a function of x. So those kind of exercises, and then evaluating functions on the next set of exercises. And then if we look at the following set of exercises, it says find the domain of each function. And now our functions are written as equations. And so that's what I'm going to do today, is teach you guys how to find the domain of a function if it's written as an equation. So suppose we have an equation of a function. So not a pictorial representation and not a set representation. Then the domain is going to be as follows. And we usually write that with a capital D. So it's going to be the set of all allowable x values. So we have an equation of a function, so it's y written as an equation in x. So we have y on one side, and we have a mixture of x's and symbols and stuff on this side. So the domain will be all allowable x values. And that particular equation would also, that particular definition would also be okay if we go on the previous representations of functions. If we call the domain our x values and the range our y values, then the domain is all the allowable x values. Well, the only allowable x values are what we have in here. And the allowable x values on something like in this form would be what your first entries are. And of course, you want to write that without any repetition. So that definition would suffice even for the previous manifestations of functions that we've had. So also in chapter 3, we are only considering the real numbers. So we're only in the real number system. So that big fancy R means the set of all real numbers. Okay, so if we're going to answer a question about what the domain is and we have an equation, what we need to do is look for restrictions on x. So what do we mean by restrictions on x? Well, where do we have restrictions? Well, two common places that we have restrictions are fractions and even roots. So when I say even roots, I mean square roots, fourth roots, sixth roots, eighth roots, and so forth. Now, with a fraction, where do you get in trouble? What is not allowed for fractions? No, just for fractions. So think of a fraction. What kind of fraction, if you put it into your graphing calculator, you get an error message? If there's 0 in the denominator. So if you try and do that, you try and tell your calculator to say, okay, what's the fraction 5 over 0? You get an error message specifically saying you divided by 0. You can't do that with a fraction. So we do have a restriction on a fraction. We're not allowed to have 0 as the denominator. So I'm just going to write DEN for denominator. Okay. Now, what about even roots? So whatever goes for a square root will also be applicable to fourth roots, sixth roots, etc. Where do you get in trouble, say, with the square root? So think of something that you would put in your calculator. So if I want to tell it to figure out the square root of something, where would I get in trouble there? If it's negative. So if I ask it to calculate the square root of negative 16, then I do get an error message, and it's telling me there is an answer, but it's not in the real number system. So there is an answer to that. In particular, it's 4i, but we're not concerning ourselves with the complex number system in chapter 3. We're only considering the real number system, and so over the reals, there is no solution. So error, it's a non-real answer. So with even roots, we're not allowed to have a negative radical. So radical is the stuff that's inside the root. Well, if you're not allowed to have a negative radical, what does that mean about the radical? The radical must be what? Well, that's only partly right. So if it can't be negative, then what possibilities are there? One is positive. What's the other one? Well, we've actually got three types of numbers: positive numbers, negative numbers, and then zero. Zero is not a negative number. Zero is not a positive number. So this is very important that we understand the difference, because it's going to make the difference between you selecting the wrong, the bogus multiple choice selection if we don't understand that. So if the radical is not allowed to be negative, then that means that the radical has to be either greater than or equal to 0. So there is not a problem. So we saw before, there is a problem if I try and divide a fraction by 0, but there's not a problem at all if I take the square root of 0. The square root of 0 is 0, okay? And 0 is not a positive or a negative number. So that is so important, I'm even going to underline it in a different color. Must be greater than or equal to 0. Okay, so let's look at a couple of examples. So I'm going to write out some functions, and we're going to see if we can tell what the domain is. So I'll start by giving it the name f of x, but we don't have to restrict ourselves to f. Okay. Actually, let's make this a little bit more interesting. There we go. All right. So those are some good ones to start with. So we do have other restrictions. Namely, there are restrictions on what logarithms can be, but we're not going to get to those until we get to the chapter on logarithmic and exponential equations. So just for now, we're going to be dealing with these two restrictions. Is there any restriction on what x can be in this equation? So ask yourself, is there any value for x? If you let x be a number, is there any number, if you put it in your calculator, that would give you an error message? No. We do not have a fraction that's got x in it, okay? And we do not have any even roots in here, okay? We have something squared, but that's not a root. That's an exponent. There's no restriction here, so x can be anything. And the way we write that is that we can either say that the domain is equal to all real numbers. So x is allowed to be any real number. Or we can write that as an interval. X is contained in the interval from negative infinity to positive infinity. So x can be any number between negative infinity and positive infinity. And it's implied that we're only talking about real numbers here. All right. Either one is fine, and both are used. So we do have to become familiar with both of these. Okay. All right. What about g of x? Are we going to have a restriction on what x is allowed to be? Yes, because we have a fraction here. So we have a fraction, and the denominator is not allowed to be 0. Okay, so that means in this specific case, 5x minus 3 is not allowed to be 0. But if we're going to say what the domain is the set of all allowable x values. So we have to express this as what x is allowed to be. And so in order to get what x is allowed to be, I need to exclude where I get in trouble. And this is not telling me what x is not allowed to be. This is telling me that I can't have 5x minus 3 being equal to 0. So I need to isolate this in terms of x. So I need to change this equation, or this non-equation, and to get x by itself. So I could do that in 2 steps. How would I do that? Add the 3 to both sides. So if 5x minus 3 is not allowed to be equal to 0, then 5x is not allowed to be equal to 3. And then finally, if 5x is not allowed to be equal to 3, and I divide both sides by 5, this says that x is not allowed to be 3/5. Okay. And now let's actually go back and look at our equation here. We get in trouble if a fraction has a denominator that's 0. And if x is equal to the number 3/5, then 5 times 3/5, well, the 5's would cancel on it. That'd give me 3, and then I'd have 3 minus 3. So that is the only number that gets me into trouble. So now what is the domain? The domain is the set of all allowable x values. So the domain for this guy, there's a formal way we can write it up, which would be x can be any real number. So this symbol here is like an epsilon, and it means x belongs to the set of real numbers. Then we draw a vertical line there, except in the case of x is not allowed to be 3/5. So what's the domain? Well, what is x allowed to be? It can be any real number as long as it's not 3/5. Or if you look in the back, it might just give a shortened version of this and say x is not equal to 3/5. Or it might give it in interval form. Now to see the interval form, let's consider the number line. And what I'm about to draw would also be acceptable as an answer, although you just don't see it written up in the back of the books or as a multiple choice example. So if I've got the number line, so we're all familiar with the number line, it's like an infinite ruler. 3/5 is going to be just slightly to the right of 0, so there's 3/5. And if I wanted to draw this on the number line, then I would exclude 3/5. So I draw a circle and leave it hollow to show I'm not including 3/5. But I want everything else. And so everything that's showing in the pink there is what x is allowed to be. Everything that's showing in the pink there is the domain. And that is a correct visual, pictorial representation using a number line of the domain. You won't see it that often. Now, why did I put it in here? Because if you're not familiar with interval notation, well, you've got to refamiliarize with it, yourself with it. And the way you can help, what can help you write something in interval notation is maybe to draw it first on the number line. So in interval notation, we read this from left to right. Is there a leftmost endpoint here on the pink? Can we find a leftmost point? No, so we'd start at negative infinity. And we come in and there are no gaps at all until we approach 3/5, and we actually have to jump over 3/5. So we would have a union symbol there and then carry on after 3/5. So all of these are correct representations of the domain. The most common representations you will see will be either set form, either one of those, or interval form. Rarely will you be asked to give a number line form because it's just too difficult to draw if it's WebWorks or MyMathLab, and it's too difficult to print for an answer in the back of the book or for a multiple choice selection. Okay? But it does help you with writing out the interval notation. All right, do we have a question on that one? Okay. Let's look at h of x. So if we're asked for the domain for h of x, and this is a multiple choice exam, you would find that one of the selections would be the same domain that we had for g. So you might see x is not equal to 3/5, or in this way. Another selection might be let me get a different colored pen. X is strictly greater than 3/5. So in interval notation, that would look like this. Oops, my bad. Okay, so it might be given in this form, in the multiple choice. So you might have to choose between that, and something else. Or it might be given in interval formation. So you'd have that as a possibility, that, maybe something else. There's always at least 4 multiple choice ones. So if this is my first selection, this is my second selection, and this is my third selection, what do you think the correct answer is going to be for the function h? What's going to be the domain? Well, more often than not, students will go for selection 2, and that's not correct. No, not for H. All right, so let's see why. Okay. So first of all, is everyone agreed that we have an even root here? That's a square root. And so what is the restriction on an even root? You're not allowed to have a negative radical. So what's inside is not allowed to be negative. Well, if it's not allowed to be negative, then what's inside has to be greater than or equal to 0. So from the restrictions on even roots, in particular a square root, the radical, what's inside, has to be greater than or equal to 0. Now again, I must get the restriction on x. This is telling me what 5x minus 3 is restricted to. And now that my symbol is a greater than or equal to, whenever you have greater than or equal to, less than or equal to, you have to be very careful, because sometimes if you do the same thing to both sides, the arrow changes. We didn't have to worry about that if the symbol was the not equal symbol. So if it's not equals or equals, you can do the same thing to both sides and nothing will change the symbol. That's not going to be the case if we have arrows involved. So we just have to be really careful. So I need to get x by itself. And so to get x by itself, the first thing I would do would be to add 3 to both sides. Would adding the same thing to both sides change the direction of the arrow? No. Would subtracting the same thing from both sides change the direction of the arrow? No. So if I add 3 to both sides, that does not change the direction of the arrow. And now to get the restriction on x, well, if I can get x by itself on the left-hand side, I can do that by dividing by 5. If I divide both sides by 5, will it change the direction of the arrow? No. It's only if you divide both sides by something negative. So if you multiply or divide both sides of an inequality by something negative, then the direction of the arrow changes. Okay, so you can multiply and divide by a positive number, it doesn't change anything. You can add or subtract both sides by the same thing, it won't change anything. Okay, so in this case, my arrow has not changed. If I divide both sides by positive 5, I have that. That is my restriction on x. That is what x is allowed to be. That is my domain. And we can check that, can't we? What happens if x is equal to 3/5? Then I have the square root of 5 times 3/5, which is 3 minus 3. I'll have the square root of 0. And we saw before in a calculator that's perfectly fine. And if x is anything bigger than 3/5, it's going to be allowed. I won't get an error in my calculator. So the number 2 is bigger than 3/5. And so 5 times 2 is 10, and 10 minus 3 is 7, and the square root of 7 is defined. Okay, the number 1 is bigger than 3/5. So if x is 1, I can have 5 times 1, which is 5, minus 3, which is 2. I get square root of 2, and that's just fine. Okay. Is x equals 0 allowed? No. Is 0 greater than or equal to 3/5? No, so 0 is not in the domain. And if I try and evaluate h at 0, I'm going to have the square root of 5 times 0 minus 3, which would be the square root of negative 3, and that is not defined over the set of real numbers. So this is one answer for my domain. Another way I can look at domain is on the number line. So I find 3/5. And according to this restriction, x is allowed to be 3/5, so I'm going to color it in. So it's not going to be hollow. And anything bigger than 3/5. So if it lives on the orange, it's allowed. So what I'm coloring in orange here is allowed. What I'm coloring in orange is the domain. And we can see that 0 is not in the orange. It's not allowed. So that's a number line presentation for what my domain is. And then finally, what about if your multiple choice selections are all in interval form? Well, if I look at the number line, going from left to right, I do have a starting point. It's at 3/5, and it is included. So I have this square bracket. And then there's no gaps, and it keeps going on forever. So I have 3 different representations of the domain, and they're all the same thing. What can x be? X can live in this interval, or x can live in the orange on this number line, or specifically written out, x is greater than or equal to 3/5. So the domain is the set of real numbers that x is allowed to be. All right. Are we good with that one? Okay, so let me put another one in here. So before we look at this guy, let me just do another one in here. So why don't I call this one capital H? What's the domain for that one? What is X allowed to be? One, two, or three? Two. Okay, it's going to be 2. So again, quite often, I'll see these being chosen. So we have to know these differences are oh so subtle. Well, first of all, we've got 2 restrictions here, don't we? Because it's a fraction. So it's going to have to obey the restriction for a fraction. But there's also an even root involved. And so as far as the even root goes, we have to abide by that restriction. So let me do this in orange. If I just consider the square root, then from the previous problem, the restriction just for the square root, if I'm not considering the fraction, is that X is greater than or equal to 3/5. Okay. But now, if I consider the restriction of the fraction, let's see if that'll show up. So if I ignore the square root and I look at this as a fraction, we are not allowed to have the denominator equal to 0. And if X is equal to 3/5, then the denominator is going to be the square root of 0, which is 0. So I have 2 restrictions. I have X is not allowed to be 3/5, and it's coupled with X is greater than or equal to 3/5. So I have to put these 2 restrictions together because you're not going to see it like that in the back of the book. It's not going to say X is not allowed to be 3/5 and X is greater than or equal to 3/5. I put these together into one statement by saying X is strictly greater than 3/5. And that takes care of both of these, doesn't it? It covers them. So this is the domain for capital H. And if I was drawing this on the number line, then I pointedly do not include 3/5 because it says here clearly X is strictly greater than 3/5. But then it can be anything else to the right of it. So if it's in the orange, it's good. And then in interval notation, I read it from left to right. I'm looking for a starting point. I'm going to start at 3/5, but we're not allowed to include it, so I have to write it with this parenthesis. And then there are no more gaps. So all of these would be the correct answer for domain for capital H of X. So where things go wrong is a student will wrongly say pick selection 1 because they only look at this as a fraction and they're only thinking of the restriction of this if it were a fraction. And if you ignore the square root restriction, then that would lead you to the wrong restriction, which is described here in number 1. If you only look at the orange and only think of what the restriction is for a square root and don't also consider that this is a fraction, then if you don't take into account that it's in the denominator of a fraction, then you're going to wrongly go for this guy. So this is a special one where we have to take into account both the fact that it's a fraction and that we have an even root. So we do get two restrictions here, but putting those together in this statement covers both of those. So it's not allowed to be 3/5, and it's either greater than or equal to 3/5. Well, those can be put together in one statement, covered by x is strictly greater than 3/5. Okay. All right, do we have a question about that one?
No.
All right. Okay, what about this guy? Sorry? No, say that again. I didn't get it.
Yeah, I think we're going to give it a 1.
It's not allowed to be. So the domain is the set of allowable x values. Are there any x values that get you in trouble here?
Yeah.
So is there anything that can be canceled here? No. No. You cannot cancel those 4s. No, 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 no. You can only do cancellation if you have products in there. If I could factor this, like we did the first day we were together, and it had an x plus 4 as one of its factors, I could cancel the x plus 4s. But to just look at this and say, oh, I'm going to cancel the 4s, you have got to get out of that habit. You cannot do that. All right, neither can you cancel one of the x's in that. You can only do cancellations like that if you have products. Okay, now, so there's no canceling involved. Is there an x value where if you put this in your calculator, it'd give you an error message?
No.
No. So any real number is allowed. X can be any real number. So you'll see the fancy R. X can be anything, or so yes, we do have a fraction, and yes, there are restrictions on fractions. Fractions are not allowed to have a denominator that is equal to 0. Now, what must happen for this denominator to be equal to 0? We would have x squared would have to be equal to -4, wouldn't it? That's the only way this denominator can equal 0. Does everyone see that? Okay, so the only place we get in trouble is if the denominator is 0. The only way the denominator will equal 0 is if x squared is -4. But in the real number system, will that ever happen? No. Okay, so when you square 0, 0 squared, you'll get 0. If you square a positive number, you get a positive number. If you square a negative number, you get a positive number. So this number x squared could only, in the real number system, will either be something positive, or in the single case, if x itself is 0, it will be 0, because 0 squared is 0. And so there's no real number that gets you into trouble. So x can be anything. There's no restriction. The domain is the set of allowable x values, and that's just fine. Okay. What is k evaluated at 0 for this function? 1. So in the video when we were evaluating functions, if I just have a number, then just rewrite the equation, and wherever there's an x, replace it with a 0. So I get 0 plus 4 all over 0 squared plus 4. So the numerator is 4, the denominator is 4, and that reduces to 1. Okay. So also, when I see problems like this on the final, so let me put these back up. Oh, what else? The ones that we've just done. And if you're asked what the domain is, a very popular bogus answer, bogus selection is this. Can you see why a student who hasn't had much practice might go for that one? Because they've maybe had enough practice. So this is a common mistake made at the beginning when you haven't done a lot of practice. They managed to remember that a fraction is not allowed to have a denominator that is 0. But that's not what the definition of domain is. The definition of domain is the allowable x values. So it's true, the denominator is not allowed to be x, but we have to tell what the restriction on x is. So if I have another function here, okay, that's actually the domain for that one. Does everyone see that? Yeah. Okay. So here, the fact that the denominator is not allowed to be 0 gives you the same answer as x is not allowed to be 0. Okay. All right, so my time has ended, and there's some students outside class here waiting to come in for the next class. Does anyone have any questions before we go? Okay, so everyone have a great weekend, and try and dive into those problems in WebWorks. See if you can get a printout and maybe work on those on paper before you try and sit, because maybe if you sit too long, it might start taking very long to load. So any problems like that, just give us some feedback, because this is the first time we're working at it. Okay, so I won't see you guys on Monday because it's Labor Day, so I'll see everybody on Wednesday. Okay, so have a great long weekend. Thank you.